In the previous lesson, displacement, velocity, acceleration, etc. have been expressed in one-dimensional reference frame. So, displacement, velocity, acceleration have been expressed in one-dimensional reference frame. And while used in describing linear motion, so we describe this thing in linear motion. So we know linear motion is one-dimensional motion. So now in this lesson, those terms will be expressed in two-dimensional reference frame. So we express this thing in two-dimensional reference frame. Two-dimensional reference frame. It is to mention that two-dimensional reference frame can be obtained by omitting one component from the three-dimensional reference frame. So we know in three-dimensional reference frame we have x-axis, y-axis, and z-axis, and we omit this z-axis. We only talk about in x and y axis. So this is the thing. Now, if the motion of a body is considered in two-dimensional plane or surface, then that is called two-dimensional motions. So, if we can describe any motion in two dimension like x-axis and y-axis, then those kind of motion is known as two-dimensional motion. For example, projectile, circular motion are two-dimensional motions. So we will discuss this projectile and circular motions in this chapter. So what is projectile? When an object is thrown obliquely into space, it is called projectile and its motion is called projectile motion. So when we throw an object obliquely in space, then that is known as projectile and the motion is known as projectile motion. So let us consider we throw a ball. So the ball will be go like this. If you throw a ball in this way, the ball will go like this. So this kind of motion is known as projectile motion. Why projectile is two-dimensional motion? Because it is go in x-axis and it is also go in y-axis, because it is go on x-axis in horizontal direction and also it is go in upwards in vertical direction. So these kinds of motion is known as two-dimensional motions, and projectile so we can say that projectile is a two-dimensional motion. When we discuss projectile, we have to know some terms. These terms are velocity of projection, also this is known as initial velocity, which is described in v naught, which will be described in v naught. The second one is angle of projection. This angle of projection, like this is known as angle of projection. In what angle of horizontal we throw the object in obliquely in space. So this is known as angle of projection. We always describe this as theta naught or sometimes is alpha naught. The third one is time of flight. Time of flight. Time of flight means how long it is on the air. Like we throw this from that point A and it will be come down that point B. So from point A to point B, how long it will be in air. This is known as time of flight. And the fourth one is range. Range means the distance of the point at which it falls plane is called the range. Like how long it will go from the thrown point to the landing point. This is known as range. This is known as range. So we know what is projectile motion, what is projectile, and we discuss some terms of projectile. In our daily life or in our everyday life, we see projectile motions regularly. Like if I take an example of projectile motion is football, cricket, missile, etc. These all projections are projectional projectile motions. So we if I told you that Messi kick a ball, the ball will if it is not in if it is not in kick in ground, then the ball will be if the ball is kick in air, then the ball will be go like this. So this is known as projectile motions. Now coming to the next part. So here we will discuss motion of projectile briefly. So let us first draw let us first draw the reference frame x-axis and y-axis. This is x-axis and this is y-axis. Suppose a body is thrown at the angle of theta with the velocity of v naught at this manner. Then the body will go like this. The body will be moved like this. So now we will talk about this whole scenario. First of all, we discussed vector component in our vector chapter. So for this v naught velocity, we know velocity is a vector quantity. So for this v naught, in the x-axis, the component of v naught will be vx naught, and the y-axis, the component of v naught will be vy naught. We represent this component of x-axis as vx naught and component of y-axis vy naught. So we can write that for vx naught, we can write vx naught will be v naught cos theta naught, as it is theta. If I write this as theta naught, the angle of projection. So vx naught will be v naught cos theta naught and vy naught will be v naught sin theta naught. V naught sin theta naught. We describe this component in x-axis component and y-axis component of this initial velocity. Now coming to the next one, we know we know an equation like v equals to v naught plus at. In linear motion, we described this equation, how we can use this information. This is known as initial velocity and this is known as final velocity. So in x component, the velocity of v naught will be after t time. So suppose after t second, we want to find out the velocity around x-axis. We want to find out velocity along x and y axis. So for x axis it will be Vx after t second. Then we can write this thing as in x axis the initial component is Vx naught. So for V naught will represent Vx naught plus 80 plus 80. But in the x axis there is no acceleration, because in the x axis the body is moving in the body is not doesn't have any change of velocity, or we can say that there is no acceleration along x-axis. So as there is no acceleration along x-axis, in the x-axis only the body is moving from a point to b point. So the a will be equals to 0. So we can find that at x-axis Vx will be Vx naught. So in the x-axis the initial component is always same for the all component at given t second. But in the y-axis, if I to find out, we can say that Vy naught plus at. But in the y-axis, the acceleration is the not the acceleration. The body is moving against the gravity against the gravity. So we represent this a as minus g because it it move against the gravity. So we will write this Vy equals to Vy naught minus of gt. Vy naught minus of gt. So we can write that we know Vx naught equals to V naught cos theta naught. So we write that Vx equals to V naught cos theta naught, and for Vy we can write this Vy equals to V naught sin theta naught minus of gt. So now we did have two more equation. So we derive two more equation. This one is Vx equals to V naught cos theta naught, and Vy equals to V naught Vy naught V naught sin theta naught minus of gt. So after t second, this equation only help us to find out after t second the component of the component velocity of x-axis and the component velocity of y-axis. So if I want to find out the actual velocity, like after t second, the at t equals to 0 second, at t equals to 0 second, the body is in that point. After t equals to t1 second, suppose the body is now at that point, and at that point we find out the component along x-axis and the component along y-axis. So if I want to find out the actual velocity, this v, then it is easy to find out. We can write the equation like v equals to vx square plus vy square. So if I know the component along x-axis and y-axis, I can find out that after t second, the velocity of that body we can find out after t second by this equation. So the equation is v equals to root over of vx square plus vy square. So I write this thing in there. After t second, v equals to root over of vx square plus vy square. So we derive three equations. One is this equation, one is this equation, and third one is this equation. Now we know another formula is s equals to v naught t plus half of at square. So along x-axis, how long after t second, how long it will go along x-axis and how long it will go along y-axis. So suppose after t second, this t second, the body is moving from A point to C point in horizontal position, and how long it will go in upwards, like C point to D point. I have to find out. So in this AC, we represent this AC as, suppose this AC point is x and CD point, CD distance is as y. So for x, we can write x equals to, as I want to find out in x axis. So instead of v naught, we will write vx naught t, and we know in x axis there is no acceleration, so we can write this thing as vx naught t equals to x equals to vx naught t, or for vx naught t we can write v naught cos theta naught into t. So for t we can write this as their manner, x by v naught cos theta naught. And for y-axis, for y component, we can write, for y the component is vy naught, so we can write vy naught t plus, we know for the y-axis the acceleration equals to minus g, so we can write this thing as minus of half of g t square. Now we represent this t, we replace this t as x by va naught cos theta naught, then we will get for vy naught we can write v naught sin theta naught. For t we can write x by v naught cos theta naught minus of half of g, and for t square we can write x by v naught cos theta naught whole square. If I solve this whole equation, I can write this equation in this manner: y equals to x tan theta naught minus gx square by 2 v naught square cos square theta naught, So if I replace this if I replace this tan theta with b, and g by 2 v naught square cos square theta naught as a, then the equation will be look like y equals to bx minus a x square, and this kind of equations is known as parabolic equation. This kind of equation is known as parabolic equation. So from that we can say that the projectile path is an parabolic equation. So now we learn four equations. If I write this equation for y equals to x tan theta naught minus gx square by, it is minus gx square by 2 v naught square cos square theta. So by that equation, after t second, we can find out how up our projectile is. So we learn four equations. So these four equations are very important in our motions of projectile. We should remember these four equations. Without of these four equations, there are more things we have to remember. Let me first clear the board. So there are 2-3 points we have to learn. The one is maximum height. So our projectile will gain a maximum height. Suppose this is the maximum height h. Suppose this is the maximum height h. So we have to find out the maximum height. This is known as range, the distance it covered. This is known as range, and I have to find out the total time it is in air. So we can cite the time of flight. time of flight. So we have to find out these three terms. So for first of all, if I want to find out maximum height of projectile, maximum height h equals to, we can write this for maximum height h equals to v naught square sine square v naught square sine square theta naught by 2g. So for maximum height we will use this formula. The second one is time of flight. Time of flight, for time of flight it is equals to capital T equals to we can write this thing as 2 v naught sine theta naught by g. And the third one is horizontal range. Horizontal range. And for horizontal range we represent as r. It is equals to r equals to v naught square sine 2 theta naught by g. Sine 2 theta naught by g. So we have to remember these three terms also. For horizontal range there is one more thing. When a javelin is thrown by a javelin thrower, there is a disc is thrown in Olympic games. Here is a technicality we have to follow. This is the horizontal range. So the horizontal range means this point A to point B. So when this range will be maximum, if the theta naught, if the sine 2 theta naught equals to when the sine 2 theta naught is maximum, then the range will be maximum of our given initial velocity. So we know for sine 2 theta naught, when the maximum value is sine is 1, the maximum value of sine is 1. So we know for we can find out sine 1 when sine equals to 90 degree. From that we find out theta naught will be 45 degree. So this is the case when a disc thrower or javelin thrower throw their disc or their javelin, they have to throw this at the angle of 45 degree so that they can get their maximum range when they throw their javelin or disc. So this is one of the important thing we have to remember. That's all for today's video. In next video we will learn we will discuss more thing on projectile. There is one point which is known as horizontal projectile, and we'll solve some questions on projectile motions. So if you like our lessons, please like this video, do subscribe to our channel. That's all for today's video. Thank you.